Today is August 1st, 2015, and I have a little concept here that, an idea that I haven't seen written in any astrophysics book. It's pertinent to this because I think the star's environment actually can play a large role in its appearances and its behaviors. For instance, just to illustrate what's going on here, I have heat baths and thermal reservoirs. You know, outer space versus water, oceans versus gaseous matter at standard temperatures and pressures. Now, I know it's easy for astronomers to assume that the area around a star where it's radiating, there's nothing in this vicinity, and it just radiates all of its heat and light and energy away from it without interacting with any of its environment. Yet, on the same side, they go ahead and say, well, stars are inside of the galaxy, are made inside of molecular clouds. Now, molecular clouds have a lot of different elements and molecules in them as well. And depending on how thick those clouds are when the star goes through them, could probably play a large role in determining the star's behavior. Now I want to go over heat baths as a concept. A heat bath basically is something that pulls the heat away from something to keep it at a stable temperature. For instance, the oceans. When the sun heats the oceans act as a heat bath. They absorb the thermal energy from the sun, and as well they cause a lot of evaporation, and a lot of clouds can build up around the oceans and spawn things like cyclones and hurricanes and very large storms and things like that because they've absorbed so much heat energy. But as well, they remain at a constant temperature. And they keep things around them at a constant temperature. They act as a heat bath. So basically, outer space acts as an incredibly efficient heat bath. You know, given its vacuum, the star can remain at its same temperature and just radiate its heat away as much as it wants. Outer space will just suck it up, and not even, its temperature won't change at all. Like, it'll remain very, very low energy, very low temperatures. With liquid water, if you had liquid water surrounding a star, what would happen to the star? Of course, well, the light from it would probably be diminished considerably, and the star would heat up the liquid water, and it would phase transition. The liquid water would, some of it would become ionized and dissociate to its hydrogen and oxygen counterparts, and then eject away from the other liquid that also can be vaporized into vapor. Now, given this isn't inside of outer space, this is just straight up liquid water surrounding the star. But that liquid water would also absorb all the heat from the star. But as well, what kind of feedback loops would be initiated if this was liquid water and the star was hitting it with lots of radiation and, that kind of stuff, and heat? What would happen? What would this look like? Would it change the behavior of the star? Say, for instance, if you had radiation going into that wall and the radiation would bounce back onto the star again, what would happen then? Because as we know, when we look at stars like the sun, there isn't really any mechanism to cause the material to bounce back into the sun again from outside of the sun. Once you get past the corona, it just keeps on going, man. It doesn't stop until it hits whatever it is it hits outside of the star, such as, the Earth or Jupiter or whatever, what have you. So say there was a large thing of liquid water around here. Would it cause the star to behave differently? Would it cause it to pulse? What would it cause the star to do? As well, what if you had a diffuse gas around it, much thicker than, you know, outer space, with this very, very thin, vacuumous heat bath? What would happen if there was gas? Of course, it would cause the star to dim considerably, and, well, as I've been reading, it would only shine in the infrared. And in order to see through the gas, you would have to look at the star through the infrared spectrum, because the heat of the star would heat up the surrounding molecules of the gas, and then you could see through it essentially, but you're not actually seeing through it, you're just seeing the gas molecules around it being heated. So you can determine how big it is from that. But that's just something I wanted to share, because a lot of stars, I'm learning, are behaving strangely. And I really don't have any explanation for them, but I think it's worth noting that these things actually exist, such as a Wolf-Rayet star, a Cepheid variable, Cepheid variable. There are others as well. These are variable stars in terms of like maybe like a day to 30 days that they dim and shrink. Not the variability of the sun, which has an 11-year cycle, but I mean on a monthly basis these things are variable. And the Wolf-Rayet star is supposedly really, really hot. I think that might be a star that's moving through a very thick area of molecular gas, and it's behaving very strangely because of it, but that is something I think it's worth looking into. Wolf-Rayet stars, supposedly they're really, really big and hot, but yeah, that's basically the main idea, is that the purity of the thermal reservoir isn't always vacuum like it is on the sun. A lot of different stars have to radiate through thick clouds, and some of them probably even radiate through areas where there's a whole bunch of water. Maybe it's not liquid, supposedly, but maybe it's a thick gas, literally like the clouds, like the atmosphere of the Earth, literally. And then you'd have a little more tumultuous gas, which would be in between vacuum and liquid, but it would be a lot thicker. Few thoughts to think about, because you know when you look at stars, when astronomers look at stars, I don't think it's fair to look at them as all being perfectly visible as they are, and then try to explain everything, ignoring their environment. Not all stars have the environment the sun does. So there's a few thoughts for people if they want to go in that direction.